Hi everyone, welcome to Science Matters. And today's topic will be all about intermolecular forces. And our learning targets for today are the following. At the end of the lesson, you should be able to determine and identify the different types of intermolecular forces and describe the characteristics of molecules with different intermolecular forces. So let's begin. Okay, I have here a very neat experiment for you to do at home. You will only need the following materials: a sewing needle, a piece of paper, and water. So I hope you can try this one. So the instructions for this experiment is you are to place the sewing needle on a little piece of paper and very gently rest the paper on the surface of the water. Okay, so when we do that, here is the result. Okay, you would see the sewing needle float on water. And the question is, why does the needle float on water? Okay, what is the main reason for that one? Okay, so you could answer me. Some kids would tell me it's because of surface tension. Okay, correct. There are forces enabling the needle to float on water, and that would be the surface tension. But what forces create surface tension? Okay. What forces create surface tension? Okay. I have here another question for you. What determines a substance to be a solid, a liquid, or a gas? We know the different states of matter, okay, but what dictates them to behave in such way? So we have solid here. Why do the particles do that? And for liquid and for gas, okay? So what determines a substance to be solid, a liquid, or a gas? So these questions are connected with, yes, the intermolecular forces. So intermolecular forces are the attractive forces between molecules and between ions or between ions and molecules. Okay, so to avoid confusion between intermolecular force and intramolecular force, I have here the following definition. So, intramolecular force that pertains to the force that holds the atoms together in a molecule. So, inside the molecule, that is the force that holds the atoms together. But for today's topic, we are going to discuss the intermolecular forces or the attractive forces between molecules. Okay, we have two molecules and then the force attracting both molecules. We have here example for intra, inside the molecule, inter is outside of each molecule. Okay. So for intermolecular forces, we have four types. We have dipole, ion and ion, and then the last one is London dispersion forces. So we will get to know each one of them today. Okay, let's start with the dipole and dipole forces. So dipole and dipole forces are attractive forces between polar molecules. Remember that one? It is an attractive force between polar molecules. Okay, so polar molecules have permanent dipoles. I hope you can still remember that. Okay, and when opposites attract, the positive end and is attracted to the negative end of the other molecule. Hence, we have the dipole and dipole forces. I have here an example. Remember hydrogen and chlorine. So when that molecule forms a bond, they are a polar molecule. Okay, they have these charges. And this negative side is attracted to that positive side. Remember, opposites attract. Okay, so hence they will form the dipole and dipole intermolecular forces that will hold both the molecules of HCl together. So polar molecules have a higher melting and boiling points than the non-polar molecules. Okay, so I have here table to show you that. Okay, I have here a non-polar compounds with the following boiling point. Comparing that to the polar molecules, they have higher boiling point and melting point because of these intermolecular forces. We have to have a great amount of energy in order to break that one. Okay? In order to break that, so those are the dipole and dipole intermolecular force. Okay, so we have here hydrogen bonding. We will visit the water molecule. Okay, so hydrogen bonding is a special case of dipole-dipole force and only exists between hydrogen atoms bonded to either fluorine, either nitrogen, or oxygen. So I have here the water molecule. We have the negative side, the oxygen one, is bonded or attracted to the hydrogen. Okay, so the hydrogen bonding is an example of the dipole and dipole intermolecular force. Okay, let's proceed. So the next one is the ion dipole force, or the attractive forces between an ion and a polar molecule. So I have here an example. We have an ion, a negatively charged ion is attracted to the positive end of the polar molecule. And then I have here a cation that is positive and attracted to the negative end of a polar molecule. So that is how the attraction works. Okay, ion, we have here an ion and a dipole. Okay, so these are most commonly found in solutions. So just imagine your table salt. You will mix that in water, and what happens then? The sodium molecules is attracted to the negative end of the water, and then the chlorine molecules or atoms is attracted to the positive end of the water. So hence we have ion and dipole forces. Okay, so the next type of force is the ion and ion forces. This is the strongest intermolecular force. And these are bonds between metal and nonmetals, okay, involving ions. So one of the defining features of salts is their extremely high melting points. Remember that we need a large amount of energy to separate the positive and negative ions. Okay, so example of that one, we have magnesium here and oxygen. They have electrostatic force of attraction between those ions. Okay. So the last type of intermolecular forces is the London dispersion forces. These are the weakest of the intermolecular forces and exist between all types of molecules, whether ionic or covalent, polar or nonpolar. So what really happens when these London dispersion forces happen? Okay, so we know that electrons reside in the electron cloud, right? Okay, sometimes there is an even distribution of electrons within that electron cloud. When that happens, that atom will have a temporary charge, um, a positive side and a negative side. It's because of the uneven distribution of electrons. So when that happens, it has temporary dipoles. So based on the simultaneous attraction of electrons of one molecule by the positive nucleus of the neighboring molecules, so here's what happens. Okay, so this end is attracted to this end, and this end is attracted to a negative end also. Okay, so the strength of force is directly related to the number of electrons and protons in a given molecule. The greater the number of electrons, the greater the force. Ayan. So we have the four types of intermolecular forces. We have the dipole, the attractive forces between polar molecules. Remember that one. Ion dipole is the attractive forces between an ion and a polar molecule. Ion attractive forces between ions. And the last one, we have London dispersion, attractive forces between temporary dipoles. Okay, so I hope you will find examples for each intermolecular forces. So those are the different intermolecular forces. Thank you for listening and see you on our next video.